Hi, this is Barry Bain. I'll give you a little background on David's talk and the next two talks that we're going to have in the SERC Talks series. In November, the SERC held a two-day workshop on continuous development and deployment for DoD systems. A lot of people are familiar with commercial organizations doing this kind of thing, like Amazon having a new release every 11 seconds and Tesla updating your car every month or every day if it's more serious. But the Defense Department frequently does new releases every year, and that's not very competitive if you're trying to keep ahead of your adversaries. And so this workshop had a whole number of speakers and about 50 attendees and then participants. And so three of the talks are the ones that we selected for the SERC Talk series this half year. So David, as we mentioned, is from the National Security Agency, which is one of the few organizations within the Defense Department which is successfully doing continuous development and deployment. And so that's what he's going to be talking about. The next two are going to be Sue Mobasser from Aerospace Corporation, who has been doing Agile leadership at Aerospace, and Steve Maynor, who is part of the SAFE organization, structure of some scalable Agile frameworks. So we're very fortunate to have David, who can summarize experience not just from the National Security Agency, but he has a tremendous breadth of experiences that involve working for a software cost estimation organization called Price Systems, an insurance company called Fidelity, a phone and electronics company in France called Alcatel, and the National Aero and then Space Agency, NASA. So yeah, he has a lot of very strong experiences, not just for the cost estimation, but for all the other things that come up in doing DevOps kind of thing. So David, we'll turn it over to you.
Thank you. So this talk is about transitioning from estimating and measuring Agile projects and the impact that moving into a DevOps development process has on that estimation process. And that's my focus. That's been my focus on software development for the past 30 years, is doing the estimation and planning and measurement of projects. So I've been looking at Agile development since 1998, roughly at Fidelity Investments, when we started adopting Scrum, and have been doing that relatively successfully until 3 or 4 years ago, when I started noticing some differences in the types and classes of user stories that I was getting on my projects, and this term DevOps came up, and so I started looking into it. So to my mind, Agile software refers to a group of software development methodologies that are based on iteratively providing software development, not necessarily a product, but releasing executable, runnable, testable code. DevOps expands on that in terms of delivering a usable and operationally valid product itself. And so it's not only delivering the software faster, but actually delivering the business and operational capability faster. and it tends to involve more stakeholders in the requirements and the functionality required in order to release the product. So that in a nutshell is what we were looking at. And I'm sure you've all seen the Agile Manifesto: individuals and interactions over process and tools, working software over documentation, collaboration over contract negotiation, responding to change over following a plan. And while the things on the right are viewed as valuable, the things on the left are more important. Now, when you start getting into government contracting, the things on the right take on some different perspective than they do in the commercial sector. So some things are required by law in terms of documentation, contracting. So the balance when you're applying Agile in the federal space is a little different than it is in the commercial space. So the federal space has not, to my mind, reaped the same process improvement benefits and cost benefits from Agile that the private sector has, but that's just because of the domain that it's being executed in. So, to my mind, what actually happened is the need for DevOps arose because we were starting to do software releases more quickly, and organizations wanted to release that functionality and capability faster out in the field. When I was at Fidelity, when we started doing Scrum releases, we would run into a brick wall in October because we had to lock the financial systems down in order to get ready for the year-end tax changes. So no new functionality was allowed between October and sometime in January when they had to provide the tax information to our customers. And there's similar stories in DoD where release cycles get locked in, and we have deployable software where we can't send it out because we're running into other issues that have to do with test and certification and security. So what's happened is, to overcome this strain, a higher level release management process was put into place. And application release automation, continuous integration, tools to support that, and continuous delivery came into play. So DevOps lets you provide products faster to the field, not just software releases. And then it's also been complemented by the release and introduction of tools that support this automation and development, deployment, and operations monitoring and testing. And in parallel with this has been the growth of cloud technology. And that's been one of the critical success factors for us at NSA. Is we've successfully deployed our own cloud infrastructure, and we have relatively inexpensive virtual machines that we can use for our development and test and integration test and system test environments. So it's allowed us to be more efficient and more effective in testing, releasing, and deploying and monitoring the systems as they go into production. And that's been a critical success factor for us. The tandem availability of these new, more sophisticated tools, higher automation, and then the cloud infrastructure to run them on. So DevOps aims at unifying and integrating development and software operations, or the production side of the house. And it strongly supports and is augmented by automation and monitoring at all steps of the software construction, from the integration, testing, and releasing to the deployment and the infrastructure. So you know what's going on with your system, you can tell what happens to it, you know how the test results are, and you've automated a lot of these practices and processes. It aims at a shorter development cycle to increase the deployment frequency and providing more dependable releases in close alignment with business objectives. So in a nutshell, what happens is when we put our DevOps teams together, it's not just the user and the software development practitioners that are sitting down together and figuring out what the user stories are, but I also have my production people, my operations people, if they're separate from production, security and compliance can all be part of the core group that's figuring out the user stories. And I made the comment up front that we started noticing difference in the user stories when we started doing measurement on our Agile projects. And what we started seeing was we were having user stories for testing and user stories for security and user stories for compliance. And these weren't non-functional user stories, but these were things that were actually getting embedded in our software capability or in our IT infrastructure where we had to actually test them. So we had to go back and start classifying. At first we said, well, these aren't appropriate user stories because these aren't things the user realized or wants to instantiate in the system. And then we took a step back and said, well, the operations people actually, in some sense, are users of the system. The compliance people are, the security people are. So we need to perhaps broaden our concept of what a functional requirement is and who the user population is when we start looking at the requirements of our system. Because what DevOps has done is it started embedding different classes and types of users into the development process as part of the iterations on the systems and the products that get released. And so that in a nutshell, along with the automation, is one of the key success factors in getting these products out more quickly and more robustly. And then one of the common terms that comes up with DevOps is this notion of minimal viable product. And this is the notion that there's a core set of functionality that provides basic capability that's sufficient to actually release a product out in the field for early adopters. Our financial people are starting to look at this as a parallel to IOC, but usually what happens is as we start rolling through, we have multiple MVPs depending on what the user classification is. So we can have 3 or 4 MVP targets depending if it's initial user, adding compliance function in, and adding security function in. So it can be viewed as a rolling set of iterations to provide the functionality. So in my view, development's integration with operations is a key change from Agile. And one of the critical success factors to this has to be the organizational structure allows you to have operations and development work together in tandem. And so when we set up our core teams now, we usually have a triad or a quad, depending on how sophisticated it gets, where I've got the users, operations, and development as a minimum working as part of the project management team. And then depending on how complicated the system is, I can add security and compliance. And if I have an audit function, we have to have reps from those on the team too. And then the cloud technology has been a godsend here because we can now have robust automated testing capability and test environments to sort of create an automated software factory that can rapidly test and deploy integrated software solutions. And one of the key things here is that we actually spend more time putting the test cases together. So in a lot of systems we're looking at, we're finding that the test artifacts, the test code, the test cases are developed to the same level of specification that our software solutions are. So when we do our measurement now on our source code for a release, we are starting to include the test code in the product base because it's being developed to the same level of specification that our product is. And then we have newer and better tools that manage the information in project management, things like Jira and Confluence, so we can get off of Microsoft Word documents and PDF files that have to go around. We can actually collaborate in the cloud and share this. And this is not just a DevOps thing. I'm seeing this being done for infrastructure as a service projects, which actually look a lot like DevOps, except they're not delivering software solutions. They're delivering IT infrastructure. So just a few words on the DevOps tools. We have integrated tools that allow you to plan for the requirements of development, the review, and the management of the system. And then highly integrated code development review, source code management tools, code merging, code analysis tools, things like Sonatype and CAST software for measuring code quality and code security, continuous building and integration and testing tools, packaging the tools into releases so you can automate the deployment and the staging and the releasing of the tools, integrating the change management systems back into the planning and requirements, and then configuration management, and then finally monitoring the applications and the end user experience. And again, one of the key aspects of this is the infrastructure as a service, software as a service, and the cloud being able to play together has enabled a lot of this to be much more efficient and practical than it was even 10 years ago. So how does this all impact the cost estimation community? Because that's the perspective I'm coming at from this. My group gets to put together the independent government estimates for all these systems. And so we have to understand what's going on in development. We have to figure out how much money is going to be needed in order to fulfill the minimum viable product requirements of the system, what the life cycle costs are going to look like, and our information flow is changing. I mean, the first thing I've already mentioned is we weren't getting just system user stories, we were getting stories from compliance and audit and security and from production and operations. And so that was a key change for us. The type of information we were getting and the format it was coming in was changing. And then in the federal sector, if this is a brand new start, I'm not going to have requirements until after the contract is awarded. So the typical cost analysis requirements document that's required for big federal projects isn't going to be written until after we award the contract. So we needed to find out a way to work around that and come up with some reasonable and rational placeholders for that. And we're going to talk about that in a minute. The other nice thing on this is instead of having a 500-page requirement document written at phase A and phase B, which then gets put on the shelf, and then we start doing incremental development and modifying it, because we have the user stories to track the requirements and document what's actually being implemented for each release, we can collect, quantify, and measure the functionality on the project as it proceeds. And this is a big improvement over classic waterfall. And then tracking those user stories and measuring them can give us an accurate inventory of the delivered capability. So we can measure source code and look at that, but that doesn't really tell us what we're building. But the user stories do. The user story tell us what my users, be they from development users or production or operations or mission users, what they've actually asked us to implement. And then the activities and the resources included in the estimation need to be adjusted. We're seeing in a lot of cases that system engineering activities are being embedded into the software development team, much like commercial systems. I can tell you when I was in financial services, we didn't have system engineers. We had an enterprise architecture group, but the system engineering activity was handled at the project management and the lead software development level of the project. And we're starting to see some movement in that direction now with our project teams, where I've got maybe a system engineering resource, but it's embedded in the software team. And then testing is also being folded into the software development, where my software engineers are actually on a lot of our projects, the ones that are doing the full testing suite through the life cycle. And the other key thing that's different is I also have a data science and data engineering function, which is now part of my team. Because there's been a recognition in the federal space, and this isn't just a DevOps thing, but it's a government light bulb going off, that most of our bang for the buck is in the data that we have in our systems and accessing the data and producing analytics on the data. So this is a new role for federal projects. I saw it in commercial space going back 20 years, but data science and data engineering in federal space is a relatively new thing from my perspective. And then the other thing that happens is 9 out of 10 times the maintenance activities are now part of the development project. So we're doing bug fixes and optimization and sustainment things as part of a project release, not as a discrete maintenance cycle. And so right now, law requires us to do a 10-year lifecycle cost as part of the cost estimate. And this is something that we're working with from the acquisition perspective to try to get some flexibility on, because that's not actually how we're running our projects. And then the operations staff is actively involved with the development and test. This becomes essential when you want to move things out into the field. You need to have the operations staff involved incrementally with the testing and the development requirements and how that gets deployed. All right, and then we're also seeing some movements in the private sector that the PMO and QA functions are merging into development. I don't expect to see that in the DoD space, again, because of legal requirements. But I am seeing where my PMO costs are being moved in a lot of instances to the project level and away from a central PMO functionality. Some of these changes may require legislative or acquisition regulation changes. So I don't know how that's going to work out. There is some piloting going on and some language coming down that some of the legal rules might be getting relaxed, but I don't have anything definitive on that yet. So how are we working these issues and how are we hoping to resolve them? Well, right now we have a collaboration going between several federal agencies to collect data, analyze data, produce and measure, and make recommended changes to business practices related to the estimation of Agile at scale or DevOps projects. And this presentation is actually one I gave to this working group back in August, and then repeated again at SERC in the latter part of the year. So the working group is made up of folks from NSA, Homeland Security, National Geospatial Agency, the Air Force, the Office of the Director of National Intelligence, and the Census Bureau. And we have two working groups which we started, one on project planning, which is going to deal with the upfront estimation issues, and then one on project tracking, which is going to deal with how we're going to track project status and progress as we proceed through the development. And we're trying to keep those agile goals and objectives in mind so we can do this as efficiently and effective as possible, and at the same time not add extra documentation or effort cost onto the programs. So that's sort of our goal and objective there. And so what we're working out right now, and this is a tentative plan, we're asking each of the participant agencies to try to analyze 4 projects. Right now, we're looking at some DevOps programs. We're looking at collecting metrics on user stories. We're trying to determine what level of viability estimating user stories are. Our feeling right now is the epics are too high level, and the user stories in most instances are written at too lower level and are going to be documented too late to actually do effective estimation. So we would like to standardize on a feature level estimation. We're trying to determine what a viable definition for a feature is. We haven't found anything official. It's sort of fuzzy what's actually out there in the field. So that's going to be one of our first initiatives, is define what we mean by a feature. And then we're looking at the stories and the epics and the features, and we're counting the transactions that are implicit in those user stories, depending on what level they're at. And by transactions, I mean putting information in the system, editing it, deleting it, querying it, reporting on it, and saving it in the file. So we count those 5 or 6 things up as a count of our transactions, and we use a very, very simplified thing called simple function points that allows us to normalize the story in the relationship model we have. And then we're trying to develop a model over time that looks at the capability needs that the epics support by domain, and see if we can come up with some averages for typical number or feature or user stories on a domain by domain basis. And so we're also trying to look at a schema to categorize the user stories in terms of functional user stories, testing tasks and activities, and then maintenance and bug fixes to start. So that's our initial objective for the working group. And then the other thing we're working on is based on the text in the user stories. We're trying to look at the verbs in the stories. And we have an initial lexicon we have in draft status, which gives the context in terms of how these verbs are used in a software requirement. And we started this because I was looking at a system earlier in the fall, and one of the requirements had configure a user interface to a spacecraft. And because I've been doing this a long time, I knew that configure in that context meant being able to set up information in the system and then also be able to modify it. So configure to me had a particular number of transactions that was implicit in the verb. And there was some discussion in the users group that not everybody would read it that same way. So we've gone through, I think we have 130 verbs so far where we actually have an initial lexicon. We've ID'd the verb. We have a definition of how it's used in terms of a software requirement, because if you look at these verbs in a dictionary and then you see how they're used in the context of a software and IT system, there can be a slight difference from the dictionary interpretation. And then we've gone out and we've looked at some online thesauruses and pulled in the synonyms for the verbs. And right now we're going in and IDing which synonyms seem to be appropriate in the context of a requirement, which ones are not. And then we're trying to automate this. So we have a couple of paths we're going down with the automation. We have a prototype commercial tool that goes in and reads requirements and does some of the functional sizing for us, called Marine. And we're going to update it with this list of verbs from the lexicon and pilot that. And then NSA actually has an internal Excel tool that goes in and does software sizing. So we actually have some Python scripts in development to take these verbs and apply them in the same fashion on the user stores we get in. So we don't have to manually read everything. We can take a first pass and automate it and then review the automated results. And then phase 2 on this is we're going to be looking at verb and noun combinations and then maybe looking at some artificial intelligence analysis of the text as we go forward. So the process we've sketched out for doing estimation initially is if I have an ongoing project and I have a history of user stories, I'm going to use that to develop what we're calling building block patterns, typical transaction per user story, normalized, and then using historical staffing to provide a calculation of how much functionality this group has typically been providing. We found when we looked at the raw user story numbers that there was too much variation in how much capability was actually being fielded. So we're using the functional size to normalize the user stories and then map that back to capability. If it's a new project, and I'm on slide 14, by the way, Mimi asked me to say that, and I completely forgot about it. I apologize. If it's a new project with no history and no user development operation team to work with, we would use the organizational patterns from the domain as a starting point for the cost estimates, and then work interactively with the team to look at the headcounts required in the team's mind to provide the capability. Data collection, we would collect code metrics, develop, test, and duplicate GOTS, COTS, and FOSS metrics. We have automated tools that we use for that, UCC from USC, UCCG, which is the government version of USC. We also are looking at the CAST automated function point tool, and we're also looking at some internal code analysis tools at NSA. And then we're also pulling user story data in from Jira or the like, Confluence would be the other one, to do the function point size measurement, user story count, maintenance task counts, and other project task counts. And I talked on the previous slide about building blocks. So we're trying to build building blocks of functionality, and it's my opinion they're going to vary by domain. So the blocks, say, from an aircraft will be different from a ground-based IT system. For the domain I'm in, we've got 3 building blocks: data ingest, data enrichment, and the data analytics that we're using to do additional work on the data that we have in-house. So data ingest, I've got my raw content data. I've got my metadata that gives context for my data content. And then I have reference data, which are outside data sources that I may bring in to provide additional information. So content would be the body of an email message. Metadata would be the heading information, email address, to time from, place from, IP address that gives you context for it. And then reference data may have geographic location, et cetera, so that gives you additional relevant information. Reference data is typically data that's getting used across multiple applications where you want to have a common repository of it and provide a common query environment, so you don't have to keep recreating for each application access to this common data. So for those of you that have worked with naval vessels, you've got Jane's reference documentation, which is a documentation of naval vessels where you can pull up all sorts of information on them. So that would be an example of a library of reference data that you may want to have. Or if you're a lawyer, there's case law reference libraries that you may want to bring into play. So those would be some examples of that. Data enrichment is my user interacting with the data. So I've got an analyst looking at something and they want to put comments in or provide context on it or translate it. So they're going to have a more complicated interaction with the data. So there's usually a complicated user interface that works with the data enrichment part of the application. And then analytics. This is usually a tabular and graphical representation of the data that you have in your system. So a basic one would be a table and a chart. A medium analytic may have data enrichment capabilities in tandem with its simple updating or commenting on. Complex ones would be more sophisticated, and I've got a picture to show you and a couple of slides on that. And then we're going to be looking at machine learning and AI in this domain. I don't have any ready answers for that yet. It's something we're exploring right now, but little or no data yet in my hands to look at that yet. So that's going to be phase 3 of this activity. So I'm on slide 16. And so this is what we look at when we talk about our building blocks. So data ingest, my content, I can add data into the system, I can query it, and I can save it. So I have 2 transactions, I have 1 file, I've got 16 simple function points, and my comment is this is adding basic mission data to the system, and it's going to take me 470 hours using average productivity, and that's my FTEs for a 3-month release. Metadata, the same thing, adding it, querying it, saving it. Metadata about mission data, time, location, etc. Same amount of hours, and then reference data, the same thing, adding, querying it, and saving it. The data enrichment, the analyst can add data to the mission data based on analysis and interpretation, so they can put it in, they can modify it, they can delete it, they need to be able to query it in order to look at it, and they can save it. So as a minimum, there would be that amount of information. There may also be some reports based on analyst interaction with the data, but as a bare minimum for our building blocks, we've got 4 transactions there, 25 simple function points, or 737 hours to build that, and that's 1.6 FTEs over 3 months. And then a basic analytic, as I said, is the table and chart with data in it, 267 hours, less than 1 FTE over a month, 3 months. A medium analytic, I've got 1, 2, 3, 5, 7 transactions there because I want to have a couple of context-sensitive queries there, and I want to produce multiple reports on it. So I've got more transactions, still 1 file to save it. So that ends up being 1,137 hours or 2.4 FTEs over 3 months. And then a complex one has more sophisticated queries, has more reports, more transactions because of that, and that's 1,804 hours, or roughly a little less than 4 people over 3 months to build it. And as you can see, the machine learning or the AI portion of this is to be determined because I don't have a solution for that yet. So I can't show you NSA analytics, but I did the next best thing. I like to use baseball examples because they're easy to explain and I can find nice pictures on them. So here's a basic chart which shows how a different pitch moves as it crosses through the strike zone. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you've got 12 potential charts there. So there's 12 pretty simple basic pictures that are coming out. And then when you start getting more sophisticated and you have multiple capabilities to change, and I'm on slide 18 now, pick and choose what team I want to have up and information on the pitch frequency and what venue I want to look at and do I have men on base. So I have all these queries and configuration options in here. And then based on that, I'm going to get a chart output here of pitch frequency and then a hit frequency over here. And then I'm going to get stat summaries here. So you can see I've got multiple queries here. I've got multiple outputs here. So this is a much more complicated analytic. And then I've also got additional ball, strike, foul, outs, and in play. And then there's more things I can do over here on the sides depending on what my context is for this. So this is not a simple analytic. This is probably multiple transactions and multiple outputs that you need to accommodate in order to develop this. And that's the end of my material.
Okay, we have questions?
We do. We have quite a few, actually. Jack, I'm not sure if you'd like to ask your question directly. If so, I can unmute you. Just 1 second.
Which question are you referring to?
Oh, we can go down the line. The first one being, David, do you acknowledge integrity requirements as well as functional?
Could you tell me what you mean by an integrity requirement?
Every system has 2 primary characteristics. One is performance, and the other one is integrity, or ready when and while needed. In the books, they talk about system availability,
yes,
but they treat that only as a little arithmetic expression, not a behavior of the system.
So we have key performance parameters on most of our systems which would deal with those integrity requirements. So I usually have an initial set, a threshold, and an objective. So we estimate to the threshold, but we try to deliver to the objective.
Give me an example, please, because I'm thinking about your estimation, meaning the probability that a system will be ready to do its mission when and while needed. And I have not seen that in the development ops material that I've seen. I haven't seen yours per se, but.
Well, I can't show you mine, but I can tell you that there'll be things like 7 by 24 operation, number of transactions ingested and processed within an hour, real-time requirements on them, and there's test cases and certification against all of those, which is the responsibility of the production side of the development team.
Good, thank you. Do you also, therefore, estimate the anticipated cognitive load on the operators?
No, my responsibility in the estimates is just for the software piece. The independent cost estimation shop is not responsible for that part of, that would be something that would belong on the project side.
Okay,
But
so then
that
you're not estimating.
that is tested and that is managed.
So then you're not estimating system integrity. You're estimating software integrity.
Well, I am. The project team would be estimating and measuring the system integrity.
Okay, thank you.
Okay, because we have to add some blue.
And then, Jack, you also had number 8. Where is the operator preparation, design, and materials development?
Yes, sir. Yes, I didn't see that.
There was a line item in the work breakdown structure that we put together as part of the cost estimate that would cover that part of the material development and that kind of a situation.
Yes. Well, you should be aware.
And that's transitioning somehow because most of the things I'm looking at are running on virtual machine corporate provided environment. And so some of that is handled by the enterprise and some of that is handled by the project depending on a case-by-case basis. With the particular minute.
I'm not.
Oh, no.
simply
I'm not taking it that way.
Okay, because Donna Rhodes at MIT is now very interested in looking deeper into this match or mismatch between development ops and operator competencies.
Yeah, well, I meant to say this and I forgot because I probably took a sip of tea and the thought left my mind. But you've got DevOps, you've got Secure Ops. There's probably actually 7 or 8 different labels that you could put on this depending on the circumstances. And I wasn't offended or taking anything as a criticism with your questions. I should have clarified before. I'm speaking just from the things I've looked at specifically myself. So that's the only context I have for this right now.
Good. I didn't put it in as a question, but I need to ask you. For 30 some years now, we've been keeping statistics on latent defects delivered into deployment. Today's data shows that even the best tested software still has latent defects at a rate of about 4 per 10,000 lines of code, which means that an autonomous vehicle, for example, coming at you at 60 miles an hour will contain about 30,000 bugs. So are you looking, does DevOps people look at anything more effective than testing?
So organizationally, I don't have access to the defect data. It's not one of the metrics that my group collects. The system engineering enterprise function at my organization is the one that looks at the defects. So I haven't looked at the raw data itself, but what I'm hearing from them is the increased tool coverage and the highly automation of the tool environment is actually giving them higher quality software than we had seen even 3 and 4 years ago. Well, so I don't have any hard data to back that up. I just have stories from my counterparts.
I appreciate that.
But I think one of the side effects is we are seeing more and more cases where my test code is being developed to a high level of quality and reusability. And so we are seeing a reduction in the cost to run regression tests on a release-by-release basis. So that would tend to reinforce in my mind the improvement in quality.
Well, be careful until you look at the efficacy of testing.
Yes.
And if it's not finding all the bugs, then cheap testing is not necessarily the best way to go.
No, it's not.
Yeah. Good. Thank you.
You mentioned that you move systems engineers into the software development, and I was wondering, with a cyber-physical system such as an autonomous car, what is that procedure? Do you have integrated product teams? At what point? Is it at the beginning that the systems and software developers work together, or what is the process that you use?
Because of the cloud environment, we actually have, in most cases, an enterprise architecture in place for the software development to be hoisted on. So a lot of the system engineering for that aspect of it, because these are IT/communication systems, a lot of the system engineering work that we're doing is actually system engineering/software development work. So I could see where if you had a car or an aircraft or a naval vessel, the system engineering relationship would be different.
Yes, I kind of thought it would be. Thank you.
Yes.
So I come from the aerospace world. So.
Well, I've played in the aerospace world too, and it's different. So at NASA, there were system engineers, and then I went to work at Fidelity, and there weren't any system engineers. So it depends where you are and what kind of things you're building.
I understand. Thank you.
A question about it's related to the previous one, which is, so DevOps is bringing more and more disciplines into the fold, into the project team. How do you avoid the design by committee? You get more and more people in the room. How do you keep from having so many voices that you have an inefficient process?
I think even in our most complicated one, which is a rather large project, the scale of the actual participants in the design is kept relatively small, say under 7 people. And it's compartmentalized, so it's modularized.
Mm-hmm. Okay, yeah.
I mean, I do have some concerns with DevOps scaling to some big cross DoD-wide enterprise systems because of the stakeholder complexity.
Right.
And I don't know that it's actually been successfully scaled to that extent. Although some of the software work on the new Joint Strike Fighter is being done in a DevOps-like environment. So anything is possible if you can delegate and break things down to point people rather than have 300 people arguing about the requirements.
Right.
Someone asked me what the name of the commercial tool was to automate requirements view. It's called Marine. And it's by a company called Log Apps in Falls Church, Virginia.
Oh, Sarah, that was your question. Thanks.
Yes, that was my question. Sorry, I just realized I was muted again, so you didn't hear my thanks.
Okay, and then John, I know you had a couple questions. You're unmuted if you'd like to ask directly.
This is John. Can you hear me all right?
Yes, we can.
Okay, I didn't know what we were supposed to do, just ask or read our text in the chat box or what. So let me go ahead and look at the chat box here for a moment. I can read the text. First question I have, 2 questions, is what are the differences between the development ops and the US DoD integrated product and process development, IPPD, methodology that includes integrated product teams, or IPPs, in which my understanding is that there's a representative from each stage of the life cycle on each stage of the life cycle.
So NSA has its own development methodology, which has been called the NSA way in the past. So our own internal practices had moved to Agile and then to DevOps. So because we're sort of a hybrid agency, we're not necessarily bound by all the process methodology requirements from DoD. So it's something we've looked at, and I've looked at, but it's something we moved away from probably 5 or 6 years ago. And actually, the Defense Science Board recommendation on moving more towards Agile and DevOps referenced the NSA Software Factory as their example in the case study for that.
So what are the differences?
I'm having trouble hearing you.
What are the differences between DevOps and IPPD?
Well, I mean, the IPT focus is more of an old waterfall approach where you actually have bigger team size. So I would say that the DevOps is more of a streamlined approach.
Yeah, but IPPD, IPTs are pretty much a general concept.
Yeah, I'm not prepared to comment on more detail on that today. I'm sorry.
Yeah, okay.
It's not something I've looked at in 5 or 6 years, and it's not something that's really relevant to me. So I'm not really qualified to comment on it more than that.
But just my observation is that DevOps is using integrated product teams. IPPD.
I mean, IPTs are there to get diverse groups communicating and collaborating, and they may be a successful technique in these cross-DoD things. But my experience has been in the past that it tends to get overcomplicated.
Okay, thanks for your question, John. And then Tony, if you want to ask your question directly, I see that you had a few as well. And I'm not sure if you're having trouble unmuting, but oh, there you go, Tony.
Can you hear me okay?
Yes, we can.
All right. Yeah, so I mean, I guess my question is really about, okay, I heard you say, and it makes sense to get requirements into things like JIRA and systems where they can be collected and measured. But have you had any experience with how do you translate from charters and statements of work to those product packages as they're developed? And the reason I ask that is often come across a situation where in certain cases, folks are looking for modular costs, if you will, for a project, say this product or this operation. What if we left that part out? Do you have anything to offer at that point, at this point on that?
Yeah, so a couple of things. So the first thing is we're dealing with globally, say my board of directors comes up with what they call capability needs statements. So these are high, say 200, 250 a year strategic goals for IT systems.
Right.
And so when I started looking and talking to the NSA DHS community about this 3 years ago, I went in talking to them about, I'm getting these high-level strategic goals, which I really can't do a cost estimate on. So how are we trying to approach this? So that was when I started talking to them about my transaction count model, and it's actually one of the things that got the users group going. So when we go in and look at the user stories, we can go in and on a user story by user story basis come up with an effort and cost per story. And so usually what happens is we end up bundling those together into features and working with the project team to figure out what features they need in the next year in order to meet a minimum viable product release. And so we will work with them and say, this thing has 45 transactions in it, and this one has 10, and here's my cost per. And so they can go in and do trade-offs based on a priority analysis. Right. But we're not seeing any. We've looked at the feature bundles so far, and we're not finding any consistency in what a feature is on a product-by-product basis. So that's one of the reasons we're hoping to come up with some better data on that. And we think the feature is the right way to go because when you're doing planning, you want to identify how many features you want to deliver in the next year. So time scale wise, it seems to be the right thing to look at in terms of estimation going forward. We're doing a lot of detailed estimates for the next year, but legally we're required to do a life cycle cost, which is full development plus 10 years of operation. So what's happening is a lot of times we're doing that estimate, and then we update the estimates annually as we start getting a rolling set of user stories coming in. Does that answer your question?
Gotcha. Yeah. Yes, it does.
And thank you for asking. I meant to say some of that in the slides, but the snowstorm has me a little distracted. So.
Oh, thank you.
Thanks for everyone joining in from their respective and snowy areas. It is 2:03, so again, thanks for joining for anybody who has to drop off now. David, if you're still okay answering some questions, we have quite a few still left.
Okay, go ahead. I'm just going to take a drink of water.
Yeah, absolutely. Matt, Ryan, and Kyler.
Why I turn my camera off.
Matt, Ryan, and Kyler, Menlo Innovations, you're unmuted and available to ask directly if you'd like.
Good afternoon. I'm Matt. I'm a quality advocate here at Menlo, and I'm with Ryan and Kyler, a couple of our developers. We are, our developers are already writing tests for the production code, and we have more and more of our clients asking for us to support continuous deployment. And so we're coming up progressively with a strategy for doing automated testing on the QA side. And we wondered, do you have any advice or experience in scoping the QA automated tests? We don't want to get so small that we're redoing the unit tests. And we wonder what scope we should have for a particular automated test, whether it's a story card or a group of story cards called a function, or a large group of story cards called an epic.
Yeah, that's not really my area of expertise, so I don't feel comfortable commenting on that.
Okay, thank you. Mind if I ask a follow-up?
No, go ahead.
I know you're focusing mostly on estimation. Do you have any information on how we should handle the estimation of the QA effort to include automated testing as we transition from an Agile to a DevOps model?
So what I've seen with us is the QA effort actually has been transitioned from a QA role into, I've got software developers essentially doing the functionality. So one of the things I would like to do, and I can't because my contracting organization doesn't give me visibility, is I don't have activity-based cost data to look at costs by resource type. I just get total cost information and total hours.
Okay, thank you.
But I can tell you when I'm working with my teams to do estimates, they're not calling out a specific QA resource or testing resource. It's being done by the composite development team. So that may be something that's peculiar to us. I don't know.
Okay, so you have developers doing the automated testing.
Yes, yep.
Are they the same developers that are also writing production code, or are you splitting the work there?
The teams I'm looking at are typically under 10 people, so it's usually a combination of both.
Okay, thank you very much.
Thanks. It looks like we have some follow-ups too from Jack. You're unmuted if you'd like to ask directly again.
Yes, thank you. We now have pretty good evidence that the Agile development method does not produce Agile operational systems. In your experience, does DevOps do a better job at producing Agile systems for the stakeholders?
Yes, it does.
Thank you.
And I've been saying this now for 3 or 4 years. and they're not bug free, but from what I'm seeing is there's fewer bugs in these systems than we would with typical agile ones. Because I've got my production test requirements and my security test requirements and my compliance test requirements being tested essentially every night we do the build.
My notion is that the DevOps generates more people who understand what the hell they've written.
It's a better communication pattern. That's probably its biggest strength. And then when you add in the automation and the improved communication, I mean, one of the cost drivers in Barry's COCOMO model is multi-site development. And from what I've seen, multi-site development with the DevOps tools to do online collaboration on the requirements and configuration control of them, and then same thing with the test environments and the production tests. A lot of those multi-site costs have been mitigated.
Good, thank you. I'm putting a URL in the question box you may want to look at regarding the multi-site. Thank you.
Thanks, Jack. I know you had a couple other questions listed. I don't know if you wanted to run through them. It looks like referring to slide 11. It looks more like notes for questions rather than direct questions themselves. Where you're, Jack, I don't know if you see it, where you're referring to, it looks like slide 11 about system efficacy and planning and tracking.
Well, yes. In slide 11, we talked about observing, planning, and tracking, but do we reach conclusions about whether or not the planning and tracking is adequate and accurate? That is the efficacy of the work, not just whether it's on schedule and on cost, et cetera.
So the function of an independent cost group is to make sure that there is sufficient money in the budget for the project in order for it to deliver successfully. So we don't evaluate the engineering appropriateness or the correctness of the decision. So, I mean, in the worst case, we could give you a cost estimate for something that doesn't work because we're not making the technical analysis. We're making, here's what you told us you wanted to build. Here's essentially how much software we think you need to do it. Here's how long that's going to take. So that part of the question in terms of the efficacy would belong on the oversight and governance and project management part of the organization. So that's not part of my role. On slide 11, what we're talking about is going in and looking at if we're going to track DevOps projects, what changes do we need to make in order to do that? And we want to pilot some projects where we take our expert opinion-based approaches and apply them and see how they work, and then feed them back into the cycle and modify our planning approach. And then you also had a question about the estimating tool SLIM. I do have experience using that. It's been a while, but I used it quite extensively when I was at Alcatel.
Good. Thank you.
And I don't understand your comments in slide 15.
I can't see it.
It says 15 compared to semantic web ISO WS.
Oh,
top quadrant.
Well, that has to do with the ontology of the data. What's a variable in a data dictionary refers to some phenomenon in the observable world. And the issue in the semantic web is that in 3 or 4 different pieces of software developed by different people, the variable names may be the same, but they refer to things quite different. So the W3C working group in ISO has been grappling with this notion of a semantic web for, I don't know, 12 years or so. And our favorite one is the Mars lander, you see, where the Brits computed the ephemeris in metric units, sent the data to JPL. JPL put it in their database, and their equations presumed it was English units, and the Mars lander didn't land.
Yeah, and that's sort of the thing we're trying to deal with the text is because we're finding the way that the verbs and nouns are being put in requirements for software systems is slightly different than what we see in what the dictionary word is.
Yes, sir. So NASA's working on a notion of fundamental units of measure.
Yep.
All right, and so it's something that I think DevOps should adopt. Thanks.
Thanks, Jack. And Carl, you're able to ask your question directly as well if you'd like to unmute. Otherwise, I can refer back to your question. It looks like it was in the chat. Where Carl's mentioning, in my experience, IPTs are more concerned with shepherding a program through the acquisition process, whereas systems engineers and software engineers focus on the agile software development and DevOps.
All right, well, thank you. This is Carl Stokes. I was answering the question I thought that came out to the group that was asking about the difference between DevOps and the US DoD's integrated product development process. And just reflecting that in my experience in the FAA, and I think someone touched on it earlier, the IPTs are usually focused on providing that stakeholder input and review and analysis of products throughout the systems acquisition lifecycle, not so much operations and maintenance, but throughout the acquisition as it goes into service. Whereas the software engineers and system engineers are more focused on Agile and or DevOps. So I was attempting to answer a question that I thought was posed to the group.
I appreciate it. I think that was actually by John Clark.
Correct.
And John, I know you have to follow up too. If John, I don't know if you want to speak to that or your further question. I think you had an additional. Barry, I don't know if you had any follow-up. Otherwise, I'd.
No, I think that covers it pretty well. And again, we will have two other SERC talks that are addressing different aspects of continuous development and deployment. And yeah, on the screen you can see Sue Mabasser, who has been aerospace's sort of conscience in how and how not to do Agile. And so she's going to talk about that sort of thing. And Steve Maynor is one of the people that works for Dean Leffingwell at SAFE and has been working primarily on applying SAFE to government projects. So we'll look forward to having you participate in these as well.
Yes, thank you so much, everyone, for joining us. Feel free to go to the SERC Talks website for follow-up on this. And just another heads up to those who might be interested, registration is now open for the Conference on Systems Engineering Research that's taking place on April 3rd and 4th. So we definitely hope to see you at this event as well as our next SERC Talk. And again, David, thank you so much for your presentation.
You're very welcome. Anything for Barry.
Okay, thanks a lot, David. Really good session.